All right, welcome back, astronomy students. Today, the topic is dark matter. And our follow-on topic in a little bit will be dark energy, because the only thing in common between them, other than the word dark in the title, is we just don't know much about it. It's kind of a mystery. So we start with the idea of dark matter. Let me describe to you first the way we know it exists, even though we can't see it or detect it any other way. Physics. One of the classes many of you have already had, some of you will have. Physics is the study of how things move and how they stay put. Everything from this simple ball, if I drop it, right, it's gonna fall, there it goes, okay? Gravity. Physics studies how things move. Physics also studies how galaxies themselves move. And some of that can be quite a mystery when we start realizing the core of the galaxy moves the way we would predict, but the spiral arms at the end don't. Okay? If a galaxy were a rigid structure, like this, what used to be a clock, and now it's, my Milky Way, okay? A rigid structure you would expect to turn in a uniform sort of way, right? Actually, it would turn this way. You would expect all parts of it to turn and locked in place relative to each other. So this star here and that star there will stay the same distance apart as they turn. But none of these are anchored together through any solid structure. So what happens is, as the galaxy turns, the parts that are further from the center, if they all started moving at the same relative speed, these further apart from the center, those are just rotating in place, these would fall further and further behind. These spiral arms would wind up thinner and thinner and twist into each other, and they wouldn't have these defined lines and these defined spaces between them. They would twist together and eventually would start looking like a solid mass instead of a bunch of individual spiral arms. Something in those outer edges of the arms is holding them in place, and they're going much faster than they should. Think about riding on a merry-go-round. If you're standing in the middle of the merry-go-round and you're going in a circle, you're not feeling a whole lot of tug outwards, but as you get towards the edge, you start feeling like your velocity is much faster. Same deal with a rotating galaxy. Something is holding these stars in their place as they move faster here than the stars closer in to the galactic center. That's weird. That tells us something is there, gravitationally pulling them in a circle faster here than they would as they rotate closer to the center of the galaxy. What is that exactly? We just don't know, my friends. That's the challenge. That's the rub. If I could say, all right, everybody, welcome back to the classroom, gather around. I've got this sample of dark energy here. Check it out. Isn't it cool? Check out dark matter. Check out this dark matter. It's pretty sweet, right? The problem is there's nothing to grab onto. It doesn't interact with light. It doesn't refract light. It doesn't capture light, bend light, or do anything to light except exert a very mild tug of gravitational force on everything around it. So it's kind of like a shadow, right? Like a black hole has a shadow of sorts that tells us it's there. Dark matter, I should say, has a hint that it actually exists, but we just can't see it, grab it, sample it, or bring it into the lab and figure out what it really is. Astrophysicists have several different ideas. Weakly interacting particles, like many of them, interacting with each other and pulling and holding galaxies in shape and pulling different parts of, empty space, exerting some gravity. So we know there's gravity, but there's no mass to account for it. That's weird. In fact, the matter that we can see, all the things in the universe we can account for, all those objects, stars, galaxies, black holes, asteroids, comets, dwarf planets, everything, even nebula, clouds of dust and particles in space. All of those we can account for. But dark matter is so much more plentiful, many times as massive as the matter we can see. That's strange. It's a mystery. That's dark matter. As Neil deGrasse Tyson aptly put it, we might as well call it Fred for all we know about it. We don't even know if it is, in fact, matter. Matter and dark matter, as he put it, is merely a code word for our ignorance. It's a way of saying we don't know what it is, but it makes gravity. Any questions? Yes, I believe there's a question in the front. No, we have no idea what it is. Next question. No, we don't know where we can find it. We just know it's not nearby. Where else could it be? What is it really? We don't know. And that's okay. Science is okay once in a while admitting we just don't know. So therein is our mystery for the day, friends. Your homework tonight, figure out what dark matter is really and submit a 16-page report, okay? Email it. No, I'm kidding. Don't do that. It's impossible at this point. But ponder the mystery. Think about it as you create these pages in your interactive notebook. And let me know if you've got questions. You know my email. Find it in Canvas. And I have two video links down in the comments below. I'd like you to take the time to watch those. After you're done with this, you're going to get Dr. Tyson's view on what is dark matter. He'll share a little bit more of his thoughts other than the ones I already paraphrased. And then there's another video on what little we know about dark matter. So I encourage you to take a look at that, comment, and if you have any questions, put those below as well. Thanks for watching, and tune in next time for our next exciting topic, which is ironically similar in its mystery, dark energy. All right, friends. Stay safe, stay healthy. We'll talk again soon. Bye.